Rightio, welcome back to 2017 WJC C4 paper. And I've just broke my pen, so I'll get another one. And this is the vectors question. This was a bit of a stinker this year. For some reason they binned the IJK and decided to have it all in terms of A and B position vectors. So it wasn't particularly nice. There's the initial diagram. It tells us OC is 50A and OD is 20B, and taking O as the origin, position vectors of A and B are little a and little b respectively. So the first thing you've got to do is make some headway of that information and draw this diagram, okay? From here to here is little a, from here to here is 5 little a, so obviously capital A to C must be 4A. From O to B is little b, and from B to D is little b. Once you've got that diagram, the question isn't actually that bad. Write down the vector AD in terms of A and B and show that the equation in R is that, okay? Well, so A to D is going negative A plus B plus B. Negative A plus 2B. We'll obviously rearrange that to get 2B minus A. So the equation of ADR is a point on it, let's use little a, plus some coefficient lambda times its direction, which we just discovered was 2b minus a. Multiply that bracket out, tidy it up a bit, so we've got a minus lambda a plus 2 lambda b, and of course you can factorize that bit there to get r equals a brackets 1 minus lambda plus 2 lambda b. 3 marks for that. In all fairness, impossible without this diagram though, so always draw the diagram. Part B then asks you to find a similar expression for the vector equation of the line BC. Let's go back to my diagram. That's going from here to here. Okay, so again that's down negative b plus 5a, which we then write as 5a minus b. The vector equation and the point on it was little b plus a different coefficient, this time mu, times the direction 5a minus b. Do the same thing, multiply that out and tidy it up. So you get R2, which I should have written that in there, R2 equals 5 mu A plus 1 minus mu B. Okay, so there are the first 5 marks. Wasn't particularly nice. And the next bit is even worse. Let me show you the question. They say the lines intersect at the point E. So that's obviously here. Find the position vector of E in terms of little a and little b, or the vectors A and B, right? Well, obviously at intersection, at the point of intersection, the coordinates are the same, so the coefficients of position vectors A and B must be equal. So we're setting up our usual pair of simultaneous equations and solving them. It's just not as nice as normal. So in R1, the coefficient of A is 1 minus lambda. And in R2, the coefficient of A is 5 mu. So you put them equal to each other. In R1, the coefficient of B is 2 lambda. In R2, the coefficient of B is 1 minus mu. So you put them equal to each other. And then you solve them as simultaneous equations. So as I did the last one by subtraction, I'll do this one by substitution. So I've rearranged this top one here to get lambda equals 1 minus 5 mu. And I've subbed it into here. So 2 brackets 1 minus 5 mu equals 1 minus mu. Multiply it out and tidy it all up. And you get 1 equals 9 mu. So obviously mu equals a ninth. Substitute that back into either of these, taking your time, and you get lambda equals 4 ninths. So to get the points of intersection now, you can go back to either of these two equations. I'll pick this one, R1. And obviously the point of intersection is the coefficients of A and B. So if lambda is 4 ninths, the coefficient of A is 1 minus 4 ninths, which is 5 ninths A. And again, lambda is 4 ninths, 2 of them is 8 ninths. So the other point of intersection is 8 ninths B. Gotta be honest, pretty horrific question. Luckily, they only give us 8 marks for it compared to the normal 13. So you just gotta suck it up and move on. Hello everyone and welcome to C4 2017 question 8 differential equations. This is a nice one this year. It's not the e to the kt question. We have a rate of increase, thank you very much, directly proportional, nice and easy, square root of n. So let's smash through this one. So dn by dt is proportional to root n, so dn by dt equals k root n, easiest mark on the paper. And then of course we separate and integrate those variables to get a general solution. So let's bring the root n over, 1 over root n integral dn. Let's bring the dt up there, gives us the integral of k dt. Obviously that's n to the minus a half because it's downstairs there. I much prefer to write it in index form. Increase the power by 1 takes it to half, divide by a half gives you 2n to the half, and that equals kt plus c. Don't forget your constant of integration. They give us some values then of t and n, so we can substitute those in and set them up as simultaneous equations. That's fairly straightforward. I've come up with 5k plus c equals 32, 7k plus c equals 40. Choose your preferred method of solving the simultaneous equations. I've gone for subtraction there, which gives me 2k is 8, so k equals 4. Substitute your value of k back into one of these to get the value of the constant c. You then get the general formula. 2 root n equals 4t plus 12. Divide through by 2. Root n equals 2t plus 6. Square both sides to get a value of n on its own, and n equals, in brackets, 2t plus 6. And that's a pretty easy 7 marks. Good morning and welcome to 2017 WJC C4 Maths Exam question 7b, integration using substitution. It's quite a juicy one, this question, as you can see. The substitution is u equals x squared plus 1, and we have to find the integral of x cubed brackets x squared plus 1 to the power 4. So let me show you how we do this one. Follow the same routine as you will have learnt in the classroom. Du by dx, differentiate that to get 2x. Then do your new limits. So when x is 1, substitute the value of 1 in there, u becomes 2. When x is 0, substitute the value in there, u becomes 1. Of course, if du by dx is 2x, then I can swap that dx at the end of the integral for 1 over 2x du, which is important. So, this is what they want us to integrate. Note now we have two new limits. I've swapped my x squared plus 1 in brackets for u to the power 4. My x cubed remains there at the moment. And I've swapped my dx for 1 over 2x du. Now, this is the bit we got to get rid of, okay? So, one of these x's will cancel here. X cubed over x is x squared, and that half I've brought out explicitly. And let's go back to the original expression, u equals x squared plus 1. That can be rearranged to get x squared equals u minus 1, and that's what I'm going to put in there for my final part of the substitution. So now I've got a half brackets u minus 1 times u to the 4. Multiply that out. That gives me a half u to the 5 minus a half u to the 4 du. For standard rules of integration, increase the power by 1, divide by the new power, gives me 1/12 u to the 6. Take away 1/10 u to the 5. Nothing too difficult in there. Chuck in the value of 2 for u there, get an answer. Then take away 1 over 10 times 2 to the power 5. Do the same for the number 1. Chuck it in, subtract your answers, and the final answer was 2.15. Pretty sure that is correct. 2 dp's. Thank you very much. 2017 C4 Maths paper, question 7a, integration by parts, pretty standard stuff. Integral of log x over x to the 4 with respect to x. Well, obviously the first thing you're going to do is bring that x to the 4 upstairs and call it x to the minus 4. We'll let u equals log x and dv by dx equals x to the minus 4. Differentiate that to get du by dx, which is obviously 1 over x. Integrate that to get v, which gives us minus x to the minus 3 over 3. This formula is in the booklet, but you probably know it off by heart. Hopefully you've used it so many times in your revision. So let's put all of these 4 things in the correct place in this formula. Going to get log x minus x to the minus 3 over 3. Take away the integral of minus x to the minus 3 over 3 times 1 over x with respect to x. That's how I've decided to write that. Minus a third log x over x cubed. Don't forget this effectively, they're actually in the same place, so that's minus a third x to the minus 4 with respect to x. Don't need to integrate that, just write it out again. And here, raise that power by 1 goes to minus 3, divide by that power gives us actually plus 1/9, but then this minus outside the integral turns it back into a minus. And don't commit the cardinal sin and forget the plus c on the end, please. Thank you very much. Good morning, and we're back to the 2017 C4 maths paper. We're on to what is a rather juicy question 6, the parametric equations. Bit of a routine to solving these. Bog standard, you're going to set up a cubic and you're going to find the values of p. So practice makes perfect on these. Let's go through it. Here's my initial values of x and y. So the first thing we need to do is do dx by dt, 2at, dy by dt, power down 3bt squared. Flip the dx by dt upside down and multiply them to get the gradient dy by dx. And not a particularly pleasant looking one, 3 over 2 bt over a. Thank you for that, WJC. Right, so we're going to put that in to our equation of a straight line, y minus b equals mx minus a. You might use y1, y2, x1, x2, whatever, doesn't matter. Swap the t parameter for the letter p because it asks you to. So our y coordinate, look up here, it will now be bp cubed. Whoop, gone off screen, do apologise. bp cubed, there. And our x coordinate will be ap squared, there. And of course our gradient we just worked out is 3bt over 2a, which goes there. Right, well luckily it tells us where we're heading. And there's no fraction in the equation we're looking for. So if we multiply everything through by 2a, 2a will go up there to give us 2ay, 2a will go up there to give us minus 2abp cubed, and then of course it will disappear from this part of the expression. So I can just multiply through here now by 3bp to give me 3bpx minus these two multiplied together, 3abp cubed. Bring this minus 2abp cubed over, becomes a plus, which leaves me with just the 3bpx on the right hand side minus one of these abp cubes on the right hand side, all equal to where they wanted us to be, 2ay on the left hand side. Right, and the next part of the question, it gives us a set of coordinates for x and y. Let me read it. It says the tangent intersects at the point 4a and 8b. It tells us to get to this cubic, that's not too difficult, and hence find the value of p. So let's go through it. So you're going to swap this x coordinate in there, this y coordinate in there. So we're going to have, this will be 16ab here, this product. This here will be 12abp, hope you can see that. And this here it is, well, nothing changes there, it's just minus abpp cubed. Hopefully you'll spot ab was the common factor, and that can just disappear out of sight to leave us the p cubed, the minus 12p, the plus 16 equals 0, which is where they told us we were going. So not too difficult. Few methods for solving a cubic. I'm a bit lazy, so I go for trial and improvement to find the first factor. 99 times out of 100, it'll be 0, 1, minus 1, 2, or minus 2. I tried 0, 1, and minus 1, none of them worked, so I went straight into 2. Chucking 2 in there, came out as 0, so p minus 2 is a factor. And then I used my factor theorem method, dividing this expression by p minus 2 to find the quadratic p squared plus 2p minus 8. Factorizing that one gives us these two other brackets here. So there are only two solutions for p, 2 and minus 4. Now that was a lot of marks, that question. 10 marks, that's a lot of marks on this paper. And usually the form comes up like this very often, so it's worth learning and practicing. 2017 C4 paper, question 5, part A. It's a pretty standard binomial expansion. These are just fun, let's be honest, so let's have a quick look at it. Our n value is -1/2, our x value is 4x. They only want it up to x squared, so we're just going to chuck those into 1 plus nx plus n minus 1x squared all over 2 factorial. So here's the substitution. I like to do these mentally because when my class type it in the calculator, they always seem to mess it up. A little bit of mental maths and you're going to get 1 minus 2x plus 6x squared. Don't forget the range of valid values. It's the easiest bit. Is mod x less than the reciprocal of that coefficient. So mod x less than 1/4. Now, part B looked a little bit annoying. Use your answer to part A to expand this. So effectively, you've got to determine what bit of this is actually this x here. Well, I've already got a 4. So what am I going to multiply the 4 by to get this? And I hope you spot this y plus 2y squared. I'm sure you did. Move the book. Okay, so our x value is now y plus 2y squared. And all I've got to do is chuck that. It's gone. Into our binomial expansion expression. So substituting in y plus 2y squared for every value of x, put it in there, put it in there, multiply that through by 2 gives you that. Square this bracket, don't forget this a squared plus b squared plus 2ab, multiply it all by 6, take your time tidying it up, and for me it all came out as 1 minus 2y plus 2y squared. Just take your time with the algebra there. There's nothing very tricky about it. Thank you and good night.